This is lesson 6.4 part 2. We're going to do a few sample problems now that involve word problems. So a rock is thrown from a bridge into a river. Its height h in meters. Above the river, t is in seconds. After it's released is represented by the equation h is equal to negative 4.9 t squared plus 82. So that's our quadratic relation to display that rock being thrown. And so first of all, I want to find out in question A, how high is the rock after 2.5 seconds? So what we have here is a situation where t is equal to 2.5 seconds. That's what we're setting our t as, 2.5 seconds. And so we're going to go and solve, we're going to go and basically just replace our t by 2.5 to find what the height is at that point. So h is equal to negative 4.9 times 2.5 squared plus 82. And if you put all that in your calculator, you're going to get that h is equal to 51.375. 51.375. And then that's going to be meters, because according to our question, h is in meters. And then you would write a therefore statement. Therefore, height at 2.5 seconds is 51.375 meters, depending on how many decimal places I ask you to round to. So when does a rock hit the water? So we have a situation where we have someone on a bridge. They're throwing the rock. The rock goes up, comes down, and hits the water. So the person starts off at a height over here, and our water we're going to assume is the height of 0. So our water is height 0. And so we want to find out at what time is h equal to 0. So essentially we are writing our equation like this. We're going to write 0, because that's our h, is equal to negative 4.9 t squared, 4.9 t squared, plus 82. You could have also written that as negative 4.9 t squared plus 82 is equal to 0. It's the same thing. I just wrote it the other way around. And so we need to find our t when height is equal to 0 in this case. And so what we're going to do is we're going to do that using the quadratic formula. So we're going to use that. We're going to use our quadratic formula to practice with it when we have an equation like this. So let's first find our a, b, and c. So our a value is the one in front of the t squared, so negative 4.9. Our b value, well, there's no x there, so our b value is 0 in this case. Our b value is 0. And our c value is going to be 82. And again, it's in its standard form. We have 0 at the end here, nothing on the other side of the equation here. If we did have something else there, we'd have to send it to the other side to make this equal to 0 so you could actually use your quadratic formula. You would write out your quadratic formula. I'd expect to see that. I'm not going to write it out here, but you would do it. And then we go in and plug in our numbers. Actually, I'll write it out just so we can have a reference to it. So x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And we can go and plug in our numbers here. So we're going to have x is equal to, our b is 0, so we don't really have to include that, but I will for completion. So minus 0 plus or minus square root of b squared, so 0 squared, minus 4 times a, which is negative 4.9, times c, which is 82, all over 2 times negative 4.9. And then so that's going to give us a value of, if we go and clean all that up, we get x is equal to 0, because negative 0 is 0, plus or minus square root of, if you plug all that in your calculator, you get 1607.2. Over 2 times negative 4.9, that's negative 9.8. And then we can go and we can do our two approaches. Remember, we're going to have plus or minus. So I'm going to do that over here. So my first step will be the x is equal to 0 plus the root. Now, I'm not going to put the 0 in, but you can. 0 plus square root of 1607.2 over negative 9.8. And we get x is equal to, if you put that in your calculator, you get negative 4.09. So that's one possibility. Now, in reality, we shouldn't have put x here. Here we should have put t, because our x is really our t in this case. So this represents our t value. T is equal to negative 4.09. But we also have the other possibility where we do x is equal to 0 minus that instead. So we have minus square root of 1607.2 over negative 9.8. And if you put that in your calculator, you get t, or x, is equal to 4.09. And so we have two possibilities here. You either choose the one that makes most sense. Are the seconds going to be negative seconds? Probably not. So this one here doesn't make sense. So we're not going to choose that one. This will be our answer. So you would write a therefore statement. So I'll write it over here. Therefore, h, or the height, is equal to 0 when, or after 4.9 seconds. And so we used our quadratic equation to solve, and we still had to interpret the best answer for the scenario, because we're not using this side of the parabola over here. We're just using the other side of the parabola. So we're choosing the best zero for the scenario, which is this one over here on the positive side. And then finally, how high is the bridge? We've seen questions like this before. You know how to do them already. But just to go over it again, when we're asking you how high the bridge is, we're basically just saying, what was your y-intercept here? So at time 0, how high were you at? What was your height? So we're setting this to time is equal to 0. And the reason we're including problems like this again, even though you've done it before, is so that you can interpret the difference between, when is h equal to 0 as opposed to time equal to 0. And we can go and plug in our equation. So h, when time is equal to 0, is negative 4.9, 0 squared, plus 82. So that means that h, this whole thing here is equal to 0, is equal to 82. Therefore, the height of the bridge, h of bridge, and you write it in full words and sentences, is 82 meters. That's how you would go about to do that. So now we're going to try example number 2 together. We'll start off. We might not have time to finish in the video, but we'll start off regardless, just to see how far we get. And again, it's important you try a variety of problems because you need to know how to apply this situation. You need to know how to apply this equation to a variety of situations. So we're going to start off with our example with our triangle. So we have a right triangle has a perimeter of 36 units. If the hypotenuse is 15 units, how long are the other two sides? So let's start off by just drawing a diagram. So always start off by drawing a diagram. Make your right angle triangle. You would use a ruler. You'd be more neat than I am. Let's put our 90-degree angle here. We know the perimeter is 36 units, and we know the hypotenuse is 15 units. So I'm going to just write down some variables here. X for one of my sides, y for the other. You could have put a and b, it doesn't really matter. And then we know this one here is 15. And so let's write out some equations. First of all, we know the perimeter is equal to 36 units. So what that means is that our perimeter is equal to x plus y plus 15. This perimeter is basically just the measure of all the sides added together. And we can make that even better. We can say that x plus y plus 15 is equal to 36. And we can simplify this a little bit to get that x plus y is equal to 36 minus 15, right? You send a 15 to the other side, or you do the inverse operation. And so you get x plus y is equal to 21. So there's one of our equations. And you could even, if you wanted to, isolate for one of the variables. And I would recommend doing that. So this is our basic setup. We'll call this equation letter A. And we'll get a different equation from this. We'll solve for x. You could have solved for y, it doesn't really matter. Let's also solve for x. So we know from this that x would be equal to 21 minus y. So this will be equation B. Now, is there something else we know? Well, let's take a look. You know from our famous theorem, and you probably already thought of this to begin with, that if you were to do x squared plus y squared, you would get 15 squared. You would get 15 squared. And so what that means is x squared plus y squared is equal to 225. And so what I want you to notice now is you have isolated x, and you have this new equation over here. Let's call this equation C. And so what we're going to do is we're going to sub, so our third step is we're going to sub B in C. And so when we do that, we get 21 minus y squared plus y squared is equal to 225. What we can do is we can expand and simplify and get a standard form. And when we get a standard form, we can then proceed to use our quadratic formula, or factoring, but we'll use quadratic formula here to practice with it, to get what our y value is. So let's expand this. I'm just going to do the work off to the side here. So we have 21 minus y times 21 minus y, because that's what 21 minus y squared is, plus y squared is equal to 225. And if you carry this out, you'll get, so 21 times 21 is 441. Then we have minus 42y, because you have minus 21, so minus 42y. And then minus y times minus y is plus y squared, plus the y squared that's on the outside there is equal to 225. And so now we get 441 minus 42y plus 2y squared is equal to 225. And then we can send a 225 to the other side to get our nice cleaned up formula. So 441 minus 225 minus 42y plus 2y squared is equal to 0 now. And so that would give us 216 minus 42y minus 2y squared is equal to 0. And I'm just going to rewrite this way. I'm going to put my y squared first, so minus 2y squared minus 42y plus 216 is equal to 0. And so what we want to do is we want to find our y value. We want to solve for y. You could try factoring, but we're going to try using our quadratic formula to do that. So we're going to be doing x is equal to, in this case we're looking for y, so we should say y is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And we're going to find what our y value is, and we can use our y value to find our x value after. And we'll do that in the next video.